Hello and welcome to the Bearded Math Man's YouTube channel. Hey, in this video, we're going to be talking about our third lesson in polynomial functions. We're going to be introducing you to some new concepts that are related to something called turning points. So our goals are as follows. We need to learn how to determine if an interval on a polynomial's graph is increasing or decreasing. I'm going to show you what that looks like. We're going to relate it to slope. We're also going to learn what a turning point is and what a turning point is not. And we're going to learn to determine the number of possible turning points of a function by looking at its degree. Now, as always, I've got some notes that are typed up in practice problems. Those are all hosted on my website, thebeardedmathman.com, and I will put a link to the specific materials related to this video in the description below. So be sure to check those out. Also, if you find it useful, helpful, wonderful, whatever, give it a thumbs up, leave me a comment. I'd love to hear from you. Let's get to it, shall we? Now, slope. You guys are familiar with slope. You're familiar with slope. This is a linear equation. It is linear because it has a constant slope. Everywhere on this line, if you pick any 2 points and you compare the slope, the rise over the run, you get the exact same number of 2, right? So 3 divided by 1.5 is 2. 2 divided by 1, 2. 1 divided by a half, 2. This is a constant slope because between any 2 points, the rise over run, the rate of change is exactly the same. You guys are familiar with that. Positive slope is increasing, negative slope is decreasing. So from left to right, if it's going up, that's called increasing. From left to right, if it's going down, that's called decreasing. So you guys are familiar with all of that right there. So this is a picture of an increasing slope, a positive slope. This is a picture of a decreasing slope, a negative slope. So let's tie those concepts into a polynomial function. Here we have a polynomial function that has, actually turns out it's a degree of 4, right? Now, if the degree of the polynomial is more than 1, it's not going to be a line. It's not going to be constant slope. It's going to be a curve. Every single point on a curve has a unique slope, or a slope that's different than the 2 points that are close to it. So we'll start talking about intervals of increasing and decreasing. So when you read a graph from left to right, if it's going down, we say that is decreasing. So for example, if I'm looking at this part right here, it's going down. Do you see? Now, I only have a limited picture. I only have a small view of this graph. This graph is going to continue to be going up. And as it's going up, it's also going left. So it's going to go left forever. It's going to continue that pattern for everywhere. It's going to be continuing to go up and to the left. So what we're going to say is that when you read a graph from left to right, this is starting up and left somewhere, and it's coming down. So this is a negative. This is a decreasing interval right here. Right here, this graph is decreasing. It's decreasing from negative infinity until I get to this point of negative 5.2. So one thing to note is when we talk about intervals of increasing and decreasing, we're going to be talking about the inputs, the x values. So the x values for this that have a decreasing, that have a negative slope, or where the graph is decreasing, is from negative infinity all the way up to 5.2. And then it switches. Do you see? And it starts going up. But it goes back down once again from 6.9 until 2.6. Between here and here, it's once again decreasing. So we have 2 intervals of decreasing slopes. So we have from negative infinity until we get to negative 5.2, and then from 0.694 until you get to 2.076. It's also decreasing. Now, it's increasing when you look at it from left to right, and it's going up. So we have 2 intervals of increasing, right? So between here and here, it's increasing. So from 5.2 to 6.694. And then once again from 0.2076 to positive infinity. Because this graph, it is going up, but it's going to the right. It's going to continue to go to the right. So you can put any number you want in here. In fact, when you have a polynomial function, the domain, which is a set of all possible inputs, is going to be from negative infinity all the way up to positive infinity. There's not going to be any sharp corners, no holes, anything like that, right? So let's talk about what a turning point is now. Do you see how when we had this change right here from decreasing to increasing, so it's going down and it turns and goes up, that's a turning point. Or when it's going up and then it turns to go down. That's a turning point. So when it changes from either increasing to decreasing, like it does here, increasing to decreasing, or from decreasing to increasing, where that change occurs is called the turning point. And this graph has 3 of them, 3 turning points. There's one here, that's from decreasing to increasing, see, going down to going up. There's another here, because we're going from increasing to decreasing, that's another turning point. And our third one is right here, because we're going from decreasing to increasing. You see? Now, let's talk about the number of turning points a polynomial function could have. So let's see a couple of examples, and we'll give you the definition. This right here, f of x equals negative 3x to the 7th plus 5x minus 2, that has a degree of 7, right? The biggest exponent is 7. The number of turning points this could have, the maximum number, is 6. Could it have 7? Could it have 8? It's going to be 1 less than the degree. So, for example, if you had a quadratic equation, the degree is 2. Right? That means that the maximum number of turning points is going to be 1. Or if you had, say, a degree of 8, well, then the maximum number of turning points is going to be 7. So for any polynomial function that has a degree of n, the maximum number of turning points is n minus 1. It's 1 less than the degree. Always and forever. Amen. Now, that's the maximum number. There's also some limits or some limits on, I don't mean that in a mathematical sense, but there's some limits on the possible number of turning points. So for example, if you have an odd degree, like 7, then the number of turning points is actually going to be an even number. It could be 6, because that's going to be the maximum, or 4, or 2, or 0. 0 is an even number. Whereas if it's an even, if the degree is even, then the number of turning points is going to be odd. So if it's quadratic, the maximum number of turning points is going to be 1, and there has to be 1. It's going to be a vertex, right? So we're going to learn more about that in the next lesson when we start talking about end behavior. But for now, like this one, the degree is 8. So that means 7 is the biggest possible number of turning points. But there could be 7, 5, 3, or 1 turning points. Yeah. Let's see a couple of examples, all of the degree 5, right? Just so we can kind of get a sense of how this works. So I've got the graph here. Its function is right there. This has 4 turning points, right? We have 1 turning point here because it's going from increasing to decreasing. And then it's going here, it's going decreasing to increasing. Now we have a short interval here. Here it's increasing and then it's decreasing again. That's another turning point. And then we're going from decreasing and then turns around to increasing. So we have 4 of them. We have 5 x-intercepts. 1, 2, 3, 4, 5. And 4 turning points. Now, if we look at the next one, we have another polynomial function with a degree of 5. This one's a little different. You see, this is actually going to have, do you see how many x-intercepts this is going to have? It's going to have 1. We actually don't see the x-axis, but we know it's going to have 1 because this is going to continue to go down forever and ever. Amen. Now we're going to assume that we have a picture of everything that's important, that there's nothing that's happening over here or, to the top right or to the bottom left. It's just going to continue that pattern because when you do a graph, you want to get a picture of all the answers. You want to get a nature of this, of how they look. So this is going to have 1 x-intercept as it continues to go down. It's going to have 1 x-intercept, right? And it has 1, 2 turning points. So yeah. And one more example, f of x equals negative 3x to the 5th. Well, this actually doesn't have a turning point. It has 1 x-intercept right here, but it does not have a turning point. And the reason why not is because a turning point is when the interval changes from decreasing to increasing or from increasing to decreasing. So here, when we start reading from left to right, we're decreasing, we're decreasing, we're decreasing. Right here, it's actually not increasing or decreasing at all. You're going to learn about why that is when you take calculus, but it's not changing here at all. It's not increasing or decreasing. It's 0. So if we're going from decreasing to 0 and then to decreasing again, well, so we're going down and then down. We never went back up. It never went to increasing. So from decreasing to decreasing again, that's not a turning point. Do you see? So a turning point is exactly when the interval goes from increasing to decreasing, like right here, this is the point where it changes. That's called the turning point, or the other way around. Here, we're decreasing and then increasing, so that point where it turns around is also a turning point. So let's put this all together for us, shall we? When you are decreasing from left to right, the graph is going down. You are increasing if, when you read it from left to right, the graph's going up, right? And a turning point is when we switch from one to the other. So from decreasing to increasing, that point where it changes is called a turning point. Or the other way around, if it goes from increasing to decreasing, the point where that changes is also called a turning point. Now, the maximum number of turning points for a polynomial function with a degree of n is n minus 1. So the maximum number of turning points is going to be one less than the degree. And if the degree is even, there's an odd number of turning points. If the degree is odd, there's an even number of turning points. So I hope this has been helpful. Please visit the link in the description below. You can try some practice problems that'll really help you to apply what you've learned here, to uncover some misconceptions, and that way you can shore those things up so that when you move on, you have a solid foundation. If it's been a helpful video, please like it and share it. Consider subscribing for notifications for more content of this nature. And I hope you have a great day. Until next time, I'll see you later.